This is the AP Calculus 2016 practice exam. We are going to be working on the free response questions and specifically for the 2020 test. And so anything that I don't think is going to be on the 2020 test, I'll skip over but tell you why. So number one, this is on page 42 of the exam. You've got a table, and I do think that you could be dealing with the problem with a table in the 2020 exam. I think that's a very, very good possibility. So I've gone ahead and written out the table here. It says the depth of water in tank A in inches is modeled by a differential and increasing function h. And part A says that use the data in the table to find an approximation for h prime of 6 and show the computations that lead to your answer. Okay, so h prime of 6 is asking us what is the slope of the tangent line at 6. Okay. For this function, we're not going to be able to get that exactly, but we could estimate it by getting the slope of the interval that surrounds 6. So that would be between 5 and 7. Okay, so h prime of 6 is approximately equal to h of 7 minus h of 5. So the number of inches at 7 minus the number of inches in the tank at 5 over 7 minus 5. So that's 18.5 minus 15.5 over 2, which is, it's going to be 3/2 or 1.5. What's the units? The units are going to be important on the 2020 test. It's right up here in the table. Inches per minute. All right, the unit for h of t divided by the unit of t. All right, that part's not so bad. Part B. This is probably the key part of this problem. It says, approximate the value 0 to 10 using a right Riemann sum, and then it asks a follow-up question, is this approximation greater than or less than the actual value? Okay, so we're going to use a right Riemann sum, 0 to 10. So this is an estimate, so it would be approximately equal to, I'm going to draw out our rectangles. Okay, Riemann sum is going to be rectangles, not going to be trapezoids. So there's a rectangle, there's a rectangle, there's a rectangle, and there's a rectangle. So a right sum, we're going to use the y value on the right side of the rectangle. So that would be this one for the first rectangle. So 3.5 is not going to be used at all. This one for the second rectangle, that's the right sum. This one for the third. This one for the fourth. All right, so our first rectangular base would be from 0 to 2. So the base is 2. The height is 10. Our second base goes from 2 to 5. So that's a base of 3 with a height of 15.5. So you can use your calculator on the 2020 test. You know, just multiply all this out. Then the third rectangle goes from 5 to 7, right? So the base is 2. The height is 18.5. And then the fourth rectangle goes, the base is 7 to 10. So the base is 3. The height is 20. All right, you multiply all that out, add it up, you get 163.5. Okay, so what is the unit going to be on that? All right, well, you're getting, that's going to be the total height, right? Total number of inches. So we're summing up all the heights from 0 to 10. Okay, that's how much water is in the tank. All right, the second part of part B says, is this approximation greater or less than? We know it's an increasing function, okay? So if we were to graph this, we know that h of t starts at 3.5 and gets up to 20. A right Riemann sum is going to overestimate. An increasing function. You've got this extra part that I'll put in blue here. This extra part, because you're using a right sum. If you were using a left sum, it would underestimate. Okay, so looking, it says, is this you would write this approximation is greater than the actual because a right, and this graph might do it, Riemann sum overestimates sorry about how I'm smushing it down in here, a rising function or an increasing function. I think you could very well get a question like that. That type of question makes the free response every year. Is it going to make the 2020 when there's only 2 free responses? I don't know, but it's definitely potential. All right, I'm going to pause this if you need to. I'm going to erase A and B, and we'll go on to C and D. Okay, part C says the depth of water in tank B, so this is a second tank, is modeled by G of T is equal to 3.2 plus 17.5 times the square root of the sine of 0.16t for 0 to 10. Find the average depth of the water in tank B over the interval 0 to 10. Okay, on the 2020 test, they're going to give you an easier function than this because they're gonna give you one that you could do by hand. But the average, I'm going to go ahead and write out how to do it for just your learning purposes, but the average depth is going to be 1 over 10, 1 over B minus A, so 1 over 10 minus 0, from 0 to 10 of G of T dt. So if you were to put this in your calculator, of course you'll get one you will do by hand if you get one like this on the 2020 test, you will get that that's 16.624 inches. So just because you need the calculator doesn't mean that I don't think this is worth going over. All right, so that's the first answer. The second one says, is this value greater or less than the average depth in tank A? All right, well, the average depth in tank A you're going to go back to part B, where it said you had a total depth when you went through the calculation of 163.5. So the average depth is going to be 1/10, 0 to 10 of, let's see, we call that h of t, dt. So that's going to be 1/10, and our answer in part B was 163.5. So that's going to be 16.35 inches. So since 16.624 is greater than 16.35, the average depth is greater in tank B. Okay, it's pretty close, but what they're looking for is can you figure out what the average depth in tank A was? Do you know that you just multiply 1/10 times that total depth? Okay, so that is part C. Let's take a look at part D. All right, part D says, according to the model, is the depth in the water in tank B increasing or decreasing at t equals 6? Well, what you need to do is figure out, let's see, and this is tank B, so figure out, is g prime of 6 greater than 0? If so, it's increasing. If it's less than 0, then it's decreasing. Remember the graph of a derivative. So the graph of when the derivative is greater than 0, it's an increasing function, right? Okay, so if we have some critical point, in this case that would be 6, all right? Or it might not be 6, but let's say it is 6. Well, it doesn't matter. You know, let's say our critical point is 4. Okay, if the value of the derivative is less than 4, remember it's increasing. If it's less than 0, if it's greater than 0 between, let's say, 0 and 4, it's increasing. So you would just put this in your calculator, all right? You would take the function g prime, you would put it in your calculator. If on the 2020 test, it's going to be one you can do by hand. Okay, but you want to find g prime of t. All right, and this particular one, g prime of 6, okay, you would just use your calculator. You could even just graph it if you wanted. Graph g of t, and then go to dy dx function. But you're not going to need that for the 2020 test. But you find it's g prime 6 is equal to 0.887, which is greater than 0, so it's increasing. So you absolutely could be given a problem like this. You'll just be doing the derivative. It'll be a derivative you can do by hand. Right? Not like this, but you need to understand how to do it. That's why I went over it, even though it's a calculator type problem. Okay, that completes number 1. Right, let's take a quick look at number 2, if you want to pause the video for a second. Or fast forward. Okay, number 2, part of it could be on the test, and part of it probably not. Okay, so particle moves along the x-axis, and it gives us a velocity equation. It also gives us an acceleration equation, and it gives us some initial information. All right, so part A says that in the interval 0 to 5, what's the velocity, when is the velocity of particle Q increasing? And we need to give a reason for our answer. So what you need to do is, in this case, you would graph the acceleration and see where acceleration is greater than 0. All right, and it happens to be the interval 0 to 3.963. Okay, so that's going to be where the velocity is increasing. So that's your reason. However, they're going to give you one you would be able to do by hand. Okay, so you would just, they probably just give you the velocity. You would take the derivative of that and get acceleration and see where that's greater than 0. Okay, but the speed is increasing. One thing to remember, speed or velocity is increasing when velocity and acceleration have what? The same sign. So they could both be negative and it could still be speeding up. I think that is a key concept to remember for this test. Part B is you're finding position. Okay, so position is equal to, you're going to integrate velocity, and that is not on the 2020 test. They could have a velocity acceleration type problem. It is a classic problem, but I wouldn't be surprised if it's not on the 2020 test, or they're not going to have one where you integrate. So if they have a velocity acceleration type problem, you're going to be taking derivatives. All right, let's look at part C. Okay, this is on page 43. So it says a second particle, r, moves along the x-axis so that its position is given by a differentiable function where x of r, okay, x is position, where we used it, our book used s. X of r, x of 1 is equal to 4, and the position x at 3 is equal to 8. So explain why there must be a time between 1 and 3 where the velocity is 2. Okay, this is mean value theorem. They've given you 2 points. The mean value theorem says the slope of the tangent line is equal to the slope of the secant line at some point. Okay, so in order to get velocity, you take the derivative, okay, velocity of r is equal to x prime of r. Okay, so let's get the slope of the secant line for x. Well, it's going to be y2 minus y1 over x2 minus x1. So 8 minus 4 over 3 minus 1. So that's going to be 4 over 2, which is 2. All right, so that, and it doesn't give a unit on that. So the explanation is the mean value theorem states that the slope of the secant line must equal the slope of the tangent line somewhere in the continuous interval. So as long as the function's continuous on that interval between 1 and 3, and it says it's differentiable, so that means it's continuous, then somewhere the slope of the tangent line has to equal the slope of the secant line. So you've got to get that mean value theorem as part of your answer. Okay. Boy, I would not be surprised if they throw that one out there. All right, well, let's look at D. All right, and see if we think something like D will be on the test. All right, part D says that at time t equals 3, the velocity of particle r in part C is -2. Are particles Q and R moving toward each other or away from each other at time t equals 3? Okay, so what we need to do is, let's find, we already know that the velocity of r at time 3 is negative. So what is the velocity of the other particle, Q, at time 3? Well, you would just plug 3 into the function in your calculator. On the 2020 test, you would just plug 3 into whatever that function is. Okay, so that function, let me look back at the problem. Just a second here. Oops. So sorry, there it is. V of 3 is going to be 1 minus 3 times the cosine of 3 squared over 5. Make sure your calculator would be in radians. I don't think that's going to be an issue on this test. All right, but the answer there is -1.49. So the particles are both moving in the negative direction. Oh, excuse me, I'm so sorry. I was confused. If you put, you're actually going to get 1.682. So this is in the negative direction, so that's left. This is in the positive direction, so that's right. So if they're moving in, one's moving to the left and one is moving to the right, you would also need to know their positions. Okay, the position, you've got the position function, so the position for Q at 3 is -1.49, and the position at R for 3 is equal to 8. Okay, so R is moving to the left, Q is moving to the right, so they are going toward each other. All right, I don't think one like this will be on the 2020 test, but so if you're sitting on the x-axis, Q is at -1.49, but it's moving to the right. R is over here at 8, but it's moving to the left because it's negative. Then that's what's happening. All right, in order to get those positions, you would have to integrate. So that's why I think this one would probably not be on the 2020 test. All right, it's just kind of figuring that out on the fly. Okay, but there was some useful information because on the 2020 test you might have to plug something in and figure out what the velocity is and know that negative means left, positive means right. Worthwhile information. All right, so that's going to be it for today's video. We'll pick up on number 3 on the 2016 test next video.